Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, clash-verge-rev, a modern proxy client built on Tauri that runs natively across Windows, macOS, and Linux. With nearly 98,000 stars and a growing community, it delivers a polished GUI experience for managing proxy configurations, making network customization accessible without sacrificing the power that developers and privacy-conscious users demand. Nearly 100,000 stars on GitHub. That is the kind of traction most open-source projects spend years chasing. Yet, clash-verge-rev has built that following while solving a problem most people pretend does not exist. How do you give a powerful, low-level network proxy engine a user interface worthy of the engineers who depend on it every day? The answer turns out to involve a programming language most front-end developers have never touched, and a design philosophy that treats the operating system itself as raw material. clash-verge-rev is a graphical desktop client for managing network proxy configurations. It wraps the Clash.Meta engine, also known as miHomo, which is a rule-based network tunnel written in Go. The project exists as a continuation of an earlier tool called clash-verge, which was abandoned. The team behind the revival has kept a rapid release cadence since picking up where the original left off. The numbers reflect genuine utility rather than viral curiosity. At 97,937 total stars and 7,151 forks, the fork-to-star ratio signals active developers building on top of it, not just passive observers. Another 129 stars were added in a single day at the time of this analysis. For a mature project, that kind of daily growth indicates sustained organic discovery, not a one-time spike. Proxy management tools have historically forced a choice between power and usability. Command line configurations for tools like Clash offer fine-grained control, but editing YAML files by hand to manage hundreds of routing rules is error-prone and opaque. Earlier graphical clients like Clash for Windows solved the visibility problem, but introduced a different one. They were built on Electron. Electron bundles an entire Chromium browser and a Node.js runtime into every application. The result was a tool that consumed several hundred megabytes of memory just sitting in the system tray and hundreds of megabytes of disk space at rest. For a utility that runs continuously in the background on developer machines, those are meaningful costs. Meanwhile, the underlying Clash.Meta engine kept evolving, adding support for newer transport protocols and more sophisticated routing rules, while the available GUI clients lagged behind or went unmaintained. clash-verge-rev addresses both problems simultaneously. It provides a full graphical interface for managing proxy profiles, nodes, and traffic rules, while using a fundamentally different technology stack that avoids those overhead penalties entirely. The architecture separates into three distinct layers, and understanding how they interact explains most of what makes the project technically interesting. The front end is built with TypeScript and modern web tooling, rendered inside the operating system's native WebView component. This is the layer users interact with directly: the profile list, the node selector, the traffic graphs. The backend is written in Rust and uses the Tauri framework. Tauri is a toolkit for building desktop applications with web frontends, but without bundling a full browser runtime. Tauri communicates between the Rust backend and the web frontend through a typed interface called IPC, or Inter-Process Communication. The frontend calls named commands defined in Rust. The Rust layer executes them and returns results asynchronously. Because the runtime is the operating system's own web view, the application ships without bundling Chromium. That single decision dramatically reduces the installed size and lowers memory usage at runtime. The third layer is where the actual proxy work happens, an external Clash.Meta binary that the Rust backend manages as a subprocess. This is the most elegant architectural decision in the project. Rather than re-implementing proxy logic, the Rust layer starts, monitors, and controls the Clash.Meta process, communicates with it through its REST API, and forwards status data to the front end for visualization. The proxy engine and the user interface are completely decoupled. Think of it as a sophisticated cockpit instrument panel wired to an engine that lives in a separate compartment. The panel does not need to understand combustion. It just needs to read the gauges and move the controls. Two capabilities stand out as technically significant. The first is TUN mode support. TUN refers to a virtual network interface, essentially a software-defined network card created in the operating system's kernel. When Clash.Meta operates in TUN mode, it intercepts all network traffic at the kernel level rather than only traffic from applications that explicitly use a system proxy setting. This matters because many applications ignore proxy environment variables entirely, so system-level proxy configuration leaves gaps. TUN mode closes those gaps. Implementing this requires platform-specific kernel interface work, and supporting it across Windows, macOS, and Linux represents genuine engineering depth. The second standout capability is the Profile Enhancement System, which supports both merge and script modes. Merge allows users to layer configuration fragments on top of a base profile without editing the original file. Script mode goes further, allowing users to write JavaScript that programmatically transforms proxy configurations at load time. This enables dynamic rule generation, conditional logic, and automated profile composition. The project's target users fall into a few identifiable categories. Developers working in environments where access to certain APIs, repositories, or cloud services is restricted by geography or policy use clash-verge-rev to route that traffic through appropriate endpoints without affecting unrelated connections. The rule-based routing engine is central here. A developer can configure specific domains to route through a proxy while leaving local network traffic completely unaffected. Security researchers and privacy-conscious users rely on TUN mode to ensure comprehensive traffic coverage, not just browser traffic or applications with explicit proxy support. Cross-platform consistency is a practical draw for anyone working across multiple machines. The WebDAV configuration sync feature allows a user to maintain a single set of proxy rules and profiles that stay current across a Windows workstation and a Linux development server simultaneously. Getting started requires downloading a release binary from the project's release page. It supports Windows on both x64 and x86 architectures, macOS 10.15, and later on both Intel and Apple Silicon, and Linux on x64 and ARM64. No compilation from source is required for standard use cases. Now, the project carries real structural risks worth naming clearly. The most significant is its dependency on Clash.Meta. Every capability clash-verge-rev offers that involves actual network traffic flows through that external binary. If the Clash.Meta project changes its API in a breaking way or goes unmaintained, the GUI layer becomes inert. This is a common pattern in the proxy tool ecosystem. GUI clients tend to outlast or fall behind the engines they wrap, and the relationship requires continuous maintenance from both sides. Cross-platform consistency is also harder than the release matrix suggests. Windows, macOS, and Linux handle network interface permissions, TUN device drivers, and system proxy configuration in substantially different ways. The existence of a dedicated WebView 2 updater script in the project files signals that the Windows WebView runtime has already caused enough compatibility issues to require dedicated tooling around it. The script-enhanced profile feature, while powerful, introduces a meaningful security consideration. A proxy configuration file downloaded from an untrusted source could contain JavaScript that executes within the application context. Users who import third-party profiles without reviewing them are accepting risk that the interface does not make immediately obvious. Clash-verge-rev earns its star count by solving a real infrastructure problem with technical care. The choice of Tauri and Rust was not aesthetic. It directly produces a lighter, faster, and more secure application than its predecessors. For developers and power users who need fine-grained cross-platform network traffic management without the overhead tax of earlier tools, this project represents the current state of the art in its category.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.